Hi everybody. In this video I'll be talking about usage of SMPC, which is secure multi-party computation in a Bitcoin chain actually. The Bitcoin, as you know, it's the most secure chain, and it's most it can be called as the father of all the chains that we have. Bitcoin follows the proof of work consensus, and in this diagram you can see the overview of Bitcoin architecture, which is from the Bitcoin core repository in GitHub. So most of the blockchains have these components like peer discovery. This is for the P2P network discovery. The RPC, which is meant for the decentralized apps to access, and the wallets, which access the storage engine, and also the connection manager module, which is very well communicating with the mempool and validators actually. So the miners and validators, they mine the blocks and they validate it based on the mempool transactions that's available, and that's the overview of any blockchain architecture. So this is much more similar to that. The only thing is that they don't have the smart contract engine like the Ethereum or the other blockchains have, and also they follow the UTXO model. They don't follow the account based or record based models that the recent chains are having. So the UTXOs are much secure, but they are much slower also. So to make it faster and to make the smart contracts programmable or accessible in the chain, a lot of layer 2 protocols have come up, and I'm going to speak about the zkBitcoin, which is the layer 2 protocol, which follows the SMPC and the zero knowledge proof related things, so that the developers can program the smart contracts and get the benefit of data availability layer from Bitcoin chain actually. So the zkBitcoin, it's nothing but a light multi-party computation protocol which verifies the zero knowledge circuits. That means that zero knowledge circuits are the layer 2 part of Bitcoin. It is not sitting in the chain, it is sitting in off-chain part, and the multi-party computation is done by SMPC committee. They have the Frost threshold signature scheme, which is the flexible round optimized the threshold signature, which Schnorr signature scheme, which is faster enough to generate the signatures and sign the transactions. So the zkBTC, as you see here, it's verifying, that is the SMPC committee is verifying the proofs generated by the ZK circuit, which follows the Plonk proof system, and you can see that in this architecture here. So it's nothing but the dApps, the programming logics are done through the smart contract 2, which is compatible with the ZK sync era, and the proofs are generated, and that the unsigned transactions are passed on to the MPC committee, where they verify the verifier ID, that is the verifier key that's been generated, and also the other inputs like new state, previous state, truncated taxation, the transaction ID, the new amount and the old amount. All those things are being passed as a public input, and based on that the MPC validates the proof. So the thing is that of course the ZK circuits are using the Plonk or the Circom, which is much compatible and mostly used, so it is much easier to generate the proofs. And there are stateless and stateful dApps in this zkBitcoin layer. The thing is that in the stateless you don't have any states like the new state or previous state, but in ZK stateful you have those things there, where you have to keep records of in which state this was happening and what was the new state that was created out of this smart contract logic, and that's been verified. That will be verified in the MPC committee, and the signed transactions will be sent to the Bitcoin, where the funds either will be locked or unlocked. So when the Alice locks the fund, it generates a proof and it is validated, and it is sent to the Bitcoin, where it is stored there, and it is the settlements are happening there, where the locking of funds happen in the Bitcoin chain. But when you want to unlock it, that is the Bob, when it wants to unlock it, it needs to have the proof, it needs to have the verify key, and based on that it is sent to the MPC committee, and it validates the transactions, and that's been sent to unlock the funds. So the same proof has to be there with the Bob also, the verify key, with the verify key. And here it follows the Frost protocols. If you want to know about the Frost signature schemes and all, I'll be able to do the video, but please comment on that. And in the MPC committee, when you follow the Frost scheme, that means that out of 10 participants, if there are only 5 participants that's honest or that is able to participate, then only those people will be needed to sign the signatures. And the private key that is distributed across this particular participants, because the private key is not able to, will not be accessible by any of one committee member. It can be it can be accessed by these 5 members together, but not in a unique manner. That means that only one member will not be able to access the entire key, which is the 0x ZK Bitcoin, which is a private key of the Bitcoin wallet. So the wallets are grouply accessible, not in a single individual manner. It will not be able to access. So the fraud transactions will not happen in this particular type of architecture here. And all the signed commitments are stored in the signed commitments vector, and also the local signed task, whichever it is signed by the MPC committee, that is also recorded in the vector. Means that out of 5 committee members, if 5 members are signing the transaction, all those signatures will be stored in the signed commitments and in the local signed tasks, and then later it will be clubbed and it will be send it to the smart contract, which will be ported to the Bitcoin chain actually. You can see the orchestrator. The orchestrator is something but an independent entity which acts as an intermediary between the MPC committee and the smart contract chain here. So orchestrator will be responsible to handle all the requests that's coming from the outside application. That means that from the ZK decentralized app, and it will collect the details, and it will be sending out the details to the external application, which means the ZK thing, and that will be passed on to the Bitcoin. So here you can see that there is no smart contract logics or any of the verification logics that's not happening in the Bitcoin chain. Everything is happening in the layer 2 chain itself. That means in the MPC and also in the ZK proof. And so it will be much faster and it will be much secure. And people doesn't have to spend the whole amount of gas, because only the settlement portion will be using the Bitcoin gas here. So that's the advantage of this chain. And there are other projects that are working apart from the ZK Bitcoin. ZeroSync, it is using the zero knowledge proofs. It's also a layer 2 thing. BitVM2, it's much more famous here, and they are using the optimistic fraud proof scenarios. It is not that it is not offering that privacy level that the ZK Bitcoin offers. So, but it is using the optimistic fraud proof scenario here. Alpen Labs, it is also following the zero knowledge proof. Only thing is that they have the new TypeScript opcode here. They introduced the new opcode, and so that's why they need to fork the Bitcoin for that to work out. That's the only advantage. Disadvantage. And the Babylon actually, it is also a layer 2 protocol, and it is also following the ZK things. But I think I need to see more details about it, and then in the later stages I'll be able to present more details about this Babylon. Discrete log contracts, this is something like it is helping the Oracle providers to submit the tasks into the chain actually. So without much hassle, the oracles will be able to submit the data, and the communication happens perfectly using the discrete log contracts. That's how it is. And the Chainway, ZKOI, these are all layer 2 protocols which all uses the zero knowledge proofs, and the ZK Bitcoin is the main one which is using the ZK proof, and also the MPC committee here. So that's how it is. And you can see the inputs, the transaction in formats that's happening here, where you can see that this is part of the unsigned transaction that's been sent to the MPC committee. So the inputs are of like the previous outputs, transaction ID, the ZK app ID, and the output ID of the ZK app, then the script signature, that is the Schnorr signatures, the witnesses, the transaction outputs, that is what is the output of that, how much Bitcoin fee that is using, all those things, unspendable transactions and spendable transactions, what all things will be added, that is all going to be part of this format. Then you have the Bob request. Bob is like if he wants to unlock the funds which the Alice has locked in the chain, he'll be able to send this format there with the Plonk proof, verify key, and the transaction information, transaction ID and transaction informations. So with this he will be able to unlock the funds, and the NPC will be able to validate it based on the verify key and the proof, and that will be sent to the Bitcoin to unlock it. So that's where the final settlement happens. So this is it. With less fees, the locking and unlocking of the transactions happens in a much more optimized and secure way here. So thank you for seeing this video, and if you have any comments, please add on. Thank you.